Yeah, very good evening, my dear students. I am Dr.M.L.N.Acharyulu, professor in Department of EC, St. Peter's Engineering College. I would like to continue the n element array of the antenna arrays. So here the linear array of n isotropic point sources of equal amplitude and spacing. So already we discussed about the 2 point sources of equal amplitude and equal spacing. But we used to take n number of elements. Then what is happening generally? Generally, you used to take the n number of elements will be taken into the account. Then the radiation pattern will give a highly directive patterns. So now the linear array, just to say, an array is a linear when the elements of the array are spaced equally along the straight line. Just you take this is the I will tell that this is the actually how the n number of point sources is placed on a particular line. Just to see that this is an x-axis, this is y-axis, and the distant point you say that p like this. The n number of sources is there. Source 1, source 2, source 3, source 4 like this up to so on n number of sources which is on the x-axis. Phi equal to 0. And the phi is equal to 90 degrees here. So now just we used to take the theoretical statement like you say that the elements are fed with the current of equal magnitude and uniform phase shift along the line. This is schematically drawn as shown in the figure. Already I told that how the diagram is there of the schematic of the n element arrays are framed like this. Consider n isotropic point sources of equal amplitude and the spacing. Then the total field E at the large distance in the direction psi is given by E is equal to the sum of all these points. Just to take source 1, source 2, source 3 like this up to so on. This should be summing. So it is at the origin one source will be there. So therefore E naught into e power 0. That means which is equal to E naught. Generally used to take E naught is the magnitude of the signal. So here this is the phase. So therefore E is equal to 1 plus e power j psi plus e power 2 j psi like this. Just will take the 1 by 1 increases psi is the phase difference. Just will take like this 1 plus e power j psi e power 2 j psi e power 3 j psi up to so on e power j into n minus 1 into psi like this. Now we'll take psi is equal to what actually already you know that the psi is equal to the beta d cos phi plus del. But here you used to take a del equal to 0, the phase difference. Now you will take what is the first one x into e power j psi which is equal to e into first e from the equation 1 you say that into e power j psi. Therefore e power j psi should be multiplied to the equation 1. So e into e power j psi which is equal to e power right side also will multiply. Then you will get instead of 1 you say that e power j psi e power 2 j psi like this. The same equation is replica here but e power j psi is multiplied. So we will get the equation number 2 is like this. This is the equation number 2. E into e power j psi equal to e power j psi plus e power 2 j psi like this up to so on e power j n psi. Now we will take the equation 2 minus equation 1. You have to subtract equation 2 minus equation 1. Then you will get what is the first equation E. Here E into e power j psi. Equation 2 minus equation 1 means E is common here. So therefore e power j psi minus 1. So how will get generally used to take the 2 minus 1 equation is E power j psi minus E like this generally. So therefore here E is common. E power j psi minus 1. So that should be replica here. Just to see, observe that. Here you take E of e power j psi minus 1 which is equal to, this is the n numbers is there, all will be cancelled, only first and last both will be left. That means the e power j n psi minus 1. Therefore E equal to, this term should be shift to the right side. Then it is e power j n psi minus 1 by e power j psi minus 1. And again you may take like this. This is the change the order 1 minus e power j n psi by 1 minus e power j psi. Now again you used to take e power j n psi by 2 is common. Therefore, e power minus j n psi by 2 minus e power j n psi by 2. Here also e power j psi by 2 common in denominator side. Then I will get e power j psi by 2 into of e power minus j psi by 2 minus e power j psi by 2 like this. And again used to take this is the upper one and I mean the numerator side which indicates that the sine function according to the trigonometric ratios. So same similarly for this also same. So you will get the resultant of this is this will be turned to the numerator side. Then you will take the result is e power j n minus 1 into psi is left. And here numerator side sin n psi by 2 by denominator sin n psi by 2, sin psi by 2. So therefore, out of this, which one it is related to the phase? It is related to the amplitude, where psi is not at all equivalent to the 0. Only this condition. This is the phase and amplitude response of the n element arrays. Now we will take directly. Just to observe that from the above equation, just to see, E is equal to e power j n psi by n psi naught minus 1 by e power j psi naught minus 1, which is 0 by 0. L-Hospital rule, you say that the psi equivalent to the 0 here. So therefore, differentiating on both sides, then dE by d psi is equivalent to the U by V method you are applying here. Just I mean L-Hospital rule, not U by V method. Just will take this is the e power j n psi into j n by e power j psi by j, e power j psi into j. So psi equivalent to the 0 just you will take and you will apply that. Then what you get, E is equal to the n. The normalizing this amplitude field pattern dividing the maximum value E is equivalent to the n, we get E is equivalent to the 1 by n into of sin n psi by 2 by sin psi by 2. This is called the array factor. Whatever we got by using of the n element array, this is the E value, maximum value of the E, which is the n elements, then 1 by n into of sin n psi by 2 by sin psi by 2. This is called the array factor, where E is equal to the n is the maximum value, means the field from the source all array at a distant point P in the same phase when psi equivalent to the 0. When it is possible actually, when psi is not equal to 0, then we got the previous equation. What is the previous equation? We got the previous equation is E equal to e power j n minus 1 into psi by 2 into of sin n psi by 2 by sin psi by 2, which is the right equation meant for the amplitude, the left equation meant for the phase. But here if the psi equivalent to the 0, then the amplitude value, the maximum, then the E is equal to 1 by n sin n psi by 2 by sin psi by 2 like this. This is called the array factor. The maximum value means the field from the source, all array at a distant point P in the same phase when psi equal to the 0. This is possible. So this is about the n element linear array.